Hi
Hello.
everyone. So great to be with you today. I'm Claudia. I am BS in Physics and BE in Computing Engineering. My area of interest is quantum computing. I'm going to share my screen now. Can you see my screen?
We can see a screen now, yes.
Perfect. My topic today, as you already mentioned, is the incorporating the advantages of CX calculus in the Tequila platform. Basically, I am here to get you excited about open source collaboration, and for that, I am going to share my experience about a recent collaboration with the Matter group from Toronto. Tequila is a package developed in Python by the Matter group related to the field of quantum chemistry. In the growing area of quantum algorithms, it happens that you have many ideas which you want to be able to test as soon as possible and show that they actually work for interesting cases. The idea of Tequila is to have a tool that allows you to develop your ideas quickly and to generate proofs of concepts. Shown here schematically, we have an example in which what you want is to minimize the square of the expected value of this trial state with some Hamiltonian. So the idea is to write code very quickly and make it easy to have an initial version that you can already test. This is what the Tequila code will look like. The goal is to place your idea that you made on a blackboard directly in code and be able to proceed with your proof of concept. There are many packages out there, such as OpenFermion, that helps create qubit Hamiltonians to simulate fermionic system. With Tequila, it is not intended to reinvent the wheel, but to efficiently use existing packages, including the possibility to translating to your resulting circuits to other packages such as Qiskit and Cirq. And as mentioned in last talk, the CX calculus is a graphical language that goes beyond circuit diagrams. Non-quantum logic gates are needed to reveal the compositional structure inside. The calculus works by generalizing the ideas of the C and X operations. Uh, this calculus defines a series of rules to represent and simplify quantum circuits, like in this simple example. And well, here's an spider, as mentioned. And also, as mentioned in the last talk, PyZX is a tool that implements the theory of CX calculus for the creation, visualization, and automated rewriting the large-scale quantum circuits. Also, you can ask the library to optimize a quantum circuit. OpenQASM is an intermediate representation for quantum instructions. The language was first described in this paper published in July 17, and a reference source code implementation was released as part of IBM's Quantum Information Software Kit, or better known as Qiskit, for use with their IBM Quantum Experience Cloud Quantum Computing Platform. This is a code example in QASM. It is currently in its version 3 that continues in development, but version 2 is still the reference for many projects. So I was in charge of transformation the Tequila circuits to PyZX circuits. The purpose was to add the ability to Tequila to optimize the circuits generated in the tool. So I have to add the communication with PyZX, but wasn't direct. I had to go through OpenQASM when converting the Tequila type circuit to a PyZX type circuit, and also in the opposite direction from PyZX to Tequila. So the first functionality that I added to Tequila was the conversion of OpenQASM code in such a way that at any time you want, you can convert the Tequila circuit to its equivalent in OpenQASM code just by calling a function export OpenQASM, and in the other direction with the function import OpenQASM. After doing that, I did the export and import to PyZX with the exposure of the functions convert to PyZX and convert from PyZX. And well, the main function of PyZX is the ability to optimize quantum circuits. The main optimization methods work by converting a circuit into a CX diagram, simplifying this diagram, and then converting it back into a quantum circuit. So what is this thing it counts? Well, increased tolerance to noise errors comes with the increased implementation overhead associated with the quantum T-gate. Because of the increased cost to realize the T-gate, T-count has become an important performance measure for fault-tolerant quantum circuit design. So, for example, this circuit, originally created in Tequila, then translated to PyZX, has a T-count of 28. And after manipulating this circuit with PyZX, we can get this other circuit, which has a T-count of only 8, which represents a great improvement. Participating in open source projects is very rewarding. It helps us gain experience and give us satisfactions in being able to do something useful that will be used by colleagues in our field of interest. The Quantum Open Software Foundation has a mentoring program in which you can collaborate on open source projects. For example, my collaboration with the Matter Group in Toronto was through this program. And in addition to the opportunity to help a project grow and gain experience, more benefits may arise. For example, I was included in the paper that talks about Tequila as a result of my contribution to the project. Thank you so much for your attention.
Thank you very much, Claudia, for that incredible talk. And that I think that connected a lot of dots, as well as introduced a bunch of new ways to implement CX calculus. I think that's really interesting. At this point, do we have any questions for our speaker? Yeah, if you have any questions, please unmute yourself or raise your hand or drop them in the chat.
Yeah, my question is about the QoSF mentorship program. Could you explain, like, I guess, what was your takeaways from that project? Thanks for going over that.
Yeah, sure. Well, I learned a lot in the sense that how to collaborate in an open source. I mean, I already know how to code, but it is different if you work with a project in which you have, in a way, a little more flexibility, but in another way, you don't have that flexibility because you have to be to be part of a team that you don't know actually, and the communication is very important. When in my case, in this program, in this mentoring program, I had a weekly meeting with one of the group, and that was very important in order to plan the things that we are that I was adding to the project. So I think it's very rewarding. I recommend it a lot.
Right. Thanks for answering that question. If there are any more questions, just let us know. I see there's a lot of people who've joined us today talking about CX calculus, so I'm sure there must be more questions on this topic. So yeah, please feel free to ask them right away. All right, next question for you, which asks, is Tequila a level above quantum circuits?
Is Tequila what? Excuse me?
Is Tequila a level above quantum circuits? So that's the question. Maybe we can.
Well, no, you in Tequila, you construct your circuit by adding gates and in a common way. I mean, you say, this is a circuit, and now I want to add a next gate, and now I want to add a CNOT gate, and in the order as usual. I mean.
Yeah, I think there's a follow-up question which asks, what does Tequila deal with? If you could maybe elaborate on that a bit.
Well, Tequila allows you to create circuits as any other similar package. But it doesn't communicate currently with D-Wave.